All right, so let's come up with something about this graph. This time, we'll start with Brianna since she volunteered. Brianna, what is something you can tell me about the graph on your whiteboard?
Well, what I can tell you about the graph just by looking at it is that May is almost as much as June, but it still isn't. So I guess there was less there.
Very good. There are fewer students in May who had a birthday than in June, but they are close. Great job. Elizabeth, why don't you take a chance?
Birthdays are in June, and it looks like the least are in August.
Fantastic, Elizabeth. The most birthdays are in June, and the least are in August. Good job. Shelby, go ahead.
Say that the most was in June.
Fantastic. The most birthdays are in June. Great job. Zana, can you tell me something about this graph?
January and April are the same.
Fantastic. January and April are the same. Great job. Brianna, you have something else to tell us?
The least amount of the months, well, the least amount of the ones that you've got on this graph is March, April, August, and November. Those are the least ones that are in this.
Fantastic. We'll take one more. Shelby, go ahead and give us one more observation about this graph.
October and May are the same.
Very good. October and May are the same. Great job. You guys did a good job. For those of you who turned in your graphs that were homework last week, great job. I told you it wasn't due until Friday of this week. I wanted to give you a full week. So I'm actually not going to share those graphs until next week because I want everyone to get a chance to do them. Elizabeth just put another observation up in the text chat that it seems like more children are born in the summer and fall than in the winter and the spring. Great observation. Now, all of the observations you made today are perfect. They're made a lot easier by making graphs. Today, we are going to talk about the phases of matter, which are solids, liquids, gases, and there's a fourth one, plasma, that you may or may not know about or have worked with. And we are going to do an activity, which this is probably my favorite class of the 9, so I'm super excited for today. And it is called the Goo Yuck Lab, where we are going to make sort of a slimy, gooey concoction. And in the end, you are going to end up making a graph about this material or the substance that we make. But before we can make our substance, we need to figure out the difference between solids, liquids, gases, and plasma. So what I'd like you guys to do is give me a little smiley face if you think you know the difference between solids, liquids, gases, and plasma for all 4. If you're not sure, give me the little not sure face. And if you think you're missing 1 or 2 of them, give me a little frown face. Just so I can kind of take a poll as to where we're starting. All right, thank you guys very much. So we're going to start up in our PowerPoint screen. And right now you should see 3 apples on your screen. And it says States of Matter, Week 3. I'm going to make mine larger so it's easier for me to see. So here we have our first slide. Does anyone want to volunteer to read this slide for me today? Brianna, go ahead.
Matter Pause. Anything that has mass and it takes up space. Everything around us, chemistry, is the study of matter and changes it undergoes.
Fantastic. Thank you, Brianna. So let's take a look at the picture on the bottom. We have a solid, a liquid, and a gas. And we have the picture showing the particles. So you all can probably think of something in your house that's an example of a solid. So here I have a solid, if you make your screen smaller, and you can see me. And I have a dry erase eraser. This is a solid. All of the particles inside this plastic dry erase marker are tightly packed together, just like the first picture shows. Now, one way for us to test if we're not sure if something is a solid would be to take a second solid. So I have my dry erase marker, I have a marker and my dry eraser. And if I push the two together, nothing happens. It doesn't go inside the solid because the particles are so tightly packed. Now, if I have a liquid, here I have a glass of water, and I'm actually going to just drop a couple of drops of food coloring in, just so it's easier for you guys to see. So I'm going to have some purple water here. Okay? And hopefully you can see it. Now, when I take my purple water and I take that same marker and I put it in, the marker goes right in because the particles are not as tightly packed. They will move to the side. Now, I don't have anything to show you for a gas, but what I am going to do is I'm going to fill a Ziploc baggie with a gas. I'm going to fill a Ziploc baggie with some air. Now my Ziploc baggie is filled with air, and it's hard to see, but the air inside the Ziploc baggie, or if you had a balloon, the air inside the balloon moves lots. You can squish it and move it around. That's because the particles are so loosely packed. Does anyone have a solid or a liquid or a gas around them right now that they would like to show us on the camera? If you do, I'll turn your camera on. All right, Brianna, I'm going to turn your camera on. Go ahead and click the OK button or the yes button underneath my video screen. That way we can see your camera. And then Shelby, I will turn yours on next. Okay, Brianna, underneath my picture, there should be a yes or an OK sign. Oh, there you go. So tell us about your solid or your liquid or your gas.
This is my mom's phone, and my liquid is this cup of water that I got, and let's see. And right now the fan is on, so that kind of counts as a gas.
All right, great job. Shelby, let's have you go. Make sure you click the little, there you go. Tell us about your solid, liquid, and or gas.
Water, and it's the liquid, and then the air around me is the gas, and the solid is pencil sharpener.
Awesome, great job, Shelby. Elizabeth, I think you had your hand up as well, so let me turn your camera on. Go ahead and click the OK or the yes button underneath my picture, please. All right, let me turn my mic off and then go ahead.
Hey, hi, and I have my solid, liquid, and gas. This is my math book. It's my solid, because, well, this is my liquid, and it has water in it, but then I also have something that you probably might not have thought of, soap. And then finally, if you can see the writing on this and the string, just don't worry. This was part of one of my projects. It's the balloon.
All right, great job. Thank you, Elizabeth. Anyone else want to share any solids, liquids, or gases? All right, Xana, go right ahead.
Here is my gas. Here is my liquid. And here.
Hold on. Click the yes or the OK button underneath my picture so your video comes through. I can't see you yet. There should be a little yes or an OK button underneath the picture so that we can see you. Can you press the yes or the OK button?
We do not see one.
Can you see my video screen?
Yes.
Underneath where my video is there something that says allow or start?
Yes.
All right, I can see you now, so go ahead.
This is my gas. This is my liquid. Some water. And this is my solid. My cup.
All right, great job, guys. You got all the major ones. I'm very impressed at how quickly you were able to assemble your solids, liquids, and your gases. Ian, do you have one you'd like to share? Let me turn your camera on and then go ahead and click the start underneath my picture.
We cannot hear you.
All right, Ian says he's having a hard time hearing me. So let's take a quick poll and make sure that it is. I can see you now, Ian. Can you give me a thumbs up if you can hear me? All right, perfect. Okay, so Ian, go ahead and turn your mic on and tell us about your solid, liquid, and or gas.
All right, there you go.
This is my liquid. And this is my gas. And this is my solid.
Awesome, great job. I love the gas coming out of the Lysol can. Perfect. You guys did a great job. So let's take a look at, now I know that you know what solids, liquids, and gases are, so let's take a little bit of a closer look behind them. So we're going to look at solids first. Solids, like my dry erase marker, like the water bottles some of you showed me. They're hard. The particles can vibrate. They can vibrate really, really fast, but they can't move. So my dry erase marker is going to be this shape forever, unless I cut it. But it's not going to change on its own. It's a fixed shape. It's a fixed volume. It's always going to take up this amount of space. And it's incompressible. Okay, Xana can't squeeze her water bottle so tight to make it change space. If she could, then it's not a solid. So liquids. Liquids like my purple water, like Ian's glue, liquids or Elizabeth's soap. The particles can move around, but they're still pretty close together. Like my water can move, but they kind of always stay attached to each other. They can change shape. If I took my purple water and I pour it into another container, hopefully without spilling it, it changes shape, but it's still water. And I did spill. It's a fixed volume, so the amount of water is not going to change. It's always going to be, if I start with a cup of water, no matter what I pour it into, it's still going to measure as 1 cup. Brianna, you have a question?
How they're supposed to stay tightly together when pretty much you're kind of ripping them apart when you put some of it in a different cup or separate it. Like
Yep, it is. You should be able to, it does separate a little bit, but if I poured this whole glass of purple water, and I don't think it'll fit into this measuring cup, there's still going to be the same amount of purple water. So you're right, you are breaking the bonds between some of the particles, but if I poured them all back together, I do have the same amount of water that I started with. So it is a fixed volume, and it's virtually incompressible. You can squeeze liquids a little bit, but not very much. Then I have gases. Gases are particles that can separate and move throughout a container. So if I have my baggie of air, which is a gas, it can move anywhere inside this baggie. I can change the shape. I can make it, squish it like this. I can squish it like this. I can squish it all together. It's easily compressed, and it's a vapor, which means it's gaseous state of a substance that is a liquid or a solid at room temperature. Now, that is a little bit of a tricky concept that I want to show you. So there are 3 ways that water can be found. As a liquid, water is water. As a solid, water is ice. And as a gas, water is water vapor or steam. Now I can't show you steam here because my stove's way on the other side of the house. But when you boil water, what's happening, that steam that's coming out, is water in the form of a gas. So our last state of matter is plasma. Now we're going to take a look at plasma. And plasma are particles that collide with enough energy to break into charged particles, positives and negatives. Plasma is very much like a gas. It can change its shape and its volume. And things that are made up of plasma are the stars. Inside of fluorescent light bulbs, there's plasma. And depending on the type of TV you have, inside some of the tubes in your TV may be something that is in the plasma state. Now, plasma is a very abstract state of matter, so we're not going to talk about it much other than to introduce you to it. What we are going to take a look at is something called phase change. And this is how the states of matter change between each other. So on your whiteboard right now, there is something called a phase change diagram. Raise your hand if you have ever seen this. Or give me a smile face. If you've ever seen this before, okay. So we're going to, go ahead, Elizabeth. Do you have a question? Or you were just raising your hand. So this phase change diagram is something that you should see soon in your science classes. The phase change diagram is a type of graph that starts at the very bottom with low temperature, so colder temperature, and as it goes up vertically, the temperature gets warmer, and as it goes to the right, there's more energy in the matter. So we're going to look at this phase change matter starting with water. Now, what is water as a solid? Raise your hand. What is the solid form of water? Xana, go ahead.
Ice.
Awesome. The solid form of water is ice. Now, if I take ice, let me get my can, and I warm it up. So I'm going to warm this ice up with my hand. I'm going to enclose it in there. What is this ice changing into? Raise your hand. I'm warming it, so I'm adding temperature to it. Brianna, go ahead.
Back into a liquid because when ice warms up, it changes back into water.
Awesome. It was changing into a liquid, which liquid water is water. So eventually, if I add enough heat to this ice cube, it's going to change into a cup of water. And now, my cup of water is at the second slant. And I'm going to warm this cup of water up. And it boils. And when this water boils, it becomes a gas. Now, what is that gas called? Anyone remember? I just told you. The gas form of water. Brianna, go ahead. Oh, I couldn't hear you, Brianna. Go ahead. What is the gas form of water?
Vapor.
Perfect, water vapor. So that just took us all the way up the steps of our phase change diagram. Take a look at the diagram with me. At the bottom where it says solid, that was ice. As it warms up and goes across the next horizontal line, it melts and it turns into a liquid. The liquid is water. As it warms up and goes up that slope, and then it boils, which is the horizontal line, it turns into a gas, which was water vapor. Now we're going to go down the phase change diagram. So we're going to start with boiling water, which is water vapor. And it's going to cool off. As it cools off, if we look on the chart, it's called condensing. And what does water vapor condense into? It's going to be the liquid form. Anyone want to make a guess? What is the liquid form of water? The liquid form of water is water. So it's going down. And now it comes to the next horizontal spot that says frozen or freezes. And when water freezes, what does it become? Shelby, go ahead. Great job. It becomes my ice cube again. You can use a phase change diagram with most liquid, gases, or solids. Water is the easiest one because it's easy for us to see. So let's take a look here. I'm going to flip through this a little because we just did some talking about it. Brianna, you have a question?
Water be all three? Like, can't it be a solid, a liquid, and it can also be a gas, right? Can't it? Because that's what I think.
Well, water can be a solid, liquid, and a gas. When water is a solid, it's just given the name ice. And when water is a liquid, it's given the name of water. And when water is a gas, it's given the name water vapor. So it is still all three. It's just what it's called. So when something changes from a solid to a liquid, it's called melting. Does anyone want to read this slide for me that I have up here about melting? Shelby, go ahead. Oops, sorry about that. Wrong button. Go ahead, Shelby.
Melting solids to liquid. Melting is the changing of a solid to a liquid when the substance absorbs heat energy. Melting point: water, table salt, diamond.
Very good. Uh-oh. Okay, very good. The melting point of water is 0 degrees Celsius. That's when water changes from a liquid to a solid. I'm sorry, from a solid to a liquid. The melting point of table salt, so like the salt that you have and you might put on food, is 801 degrees Celsius. That's when it changes from a solid to a liquid. And the melting point of a diamond, which is very hard, is 3,700 degrees. So here we have the next slide. So the next slide is going from a liquid to a solid, which is called freezing. Does anyone want to volunteer to read that? Go ahead, Elizabeth.
Opposite of melting, liquid changing into a solid is freezing. Freezing occurs when a substance loses heat energy. The freezing point of a substance is equal to the melting point.
Very good. So freezing is the opposite of melting. And we're going to go just to one more slide here. Okay. And this slide I want to talk to you about condensation. Now, condensation is what's happening on the outside of my glass of ice. And it's probably hard for you guys to see. But condensation are the little droplets of water that form on the outside of a cold cup. Condensation occurs when the water vapor in the surrounding air, so the air in my house, loses heat energy when it comes in contact with a cold glass. So this cold glass of ice is trying to cool off all the air in my house. It's not going to be able to do it, but what it does do is form little drops of water or liquid on the outside of my glass. Now what we are going to do now is we are going to do our lab. So go ahead and get your supplies for me. Okay, I'm going to put this up. When you have your supplies, click yes. For this, you need cornstarch, a little water, a cup, a baggie, a pencil or pen, sheet of paper, and food coloring if you want. So once you have your supplies, go ahead and click yes. If you are not going to do the lab today, then along with me, then go ahead and click yes so I'm not waiting for you. All right, I'm going to give you guys another minute. Remember, you're supposed to be making sure you look at your syllabus so you know what we have, what we need, and what we don't need for class. Okay, I'm waiting for 2 more people. If you're not going to do the lab with me, that's fine. Just go ahead and click yes so I don't wait. Okay, for those of you who are waiting, but have your supplies, you should start by covering your work area with something. I'm going to use wax paper. I'm just going to put it down in front of me so that if I spill, it goes on my wax paper. So I'm going to just put my camera, there you go, on my wax paper. Oops, sorry guys. What we are going to do in this lab is we are going to try to determine if the substance we make is a solid, a liquid, or a gas. Now, I'm not going to make you write a lab report about this, but we are going to make a hypothesis. So here is our problem. Our problem is the matter we are about to make out of cornstarch and water, a solid, a liquid, or a gas. On your scrap piece of paper, go ahead and write down either solid, liquid, or gas. Remember, your hypothesis cannot be wrong. I just want you to make a guess. So what is your hypothesis? Is it a solid, a liquid, or a gas? I have mine written down. Now we are going to complete this chart. You do not need to write this chart down. We're just going to do it together. So if we're going to make this mixture, and if it takes the shape of its container, is it a solid, a liquid, or a gas? There may be more than one answer. If it takes the shape of its container, do we have solid, liquid, or gas? Xana, go ahead. What do you think?
Liquid.
Liquid is one possibility, but a gas will also take the shape of its container. So if it takes the shape of its container, it can be a liquid or a gas. Now the next one says it has its own definite shape. If something has its own definite shape and the shape is not changing, is that a solid, a liquid, or a gas? Shelby, go ahead.
Solid.
Awesome, a solid, very nice. It can fill up an area larger than itself. Now that's a little bit strange wording, but what I meant by that is it can change its area. So like a solid doesn't change, it's always going to be this shape. Is there anything that can change? The answer there would be a gas. A gas can change its shape. It can be poured. Can a solid, liquid, or gas be poured between two containers? Anyone want to make a guess? Elizabeth, go ahead.
Liquid can.
Good job, a liquid can. All right, this one is just a guess for you. I'm not expecting you know this. Can it bounce? Can either a solid, a liquid, or a gas bounce? Brianna.
Well, to me, I don't exactly know, but I am pretty sure that it's probably a solid or something. Like,
Very good, a solid, like a bouncy ball, can bounce. Can be shattered with a hammer. So if we were to hit this object with a hammer, if it's a solid, a liquid, or a gas, can it break? Let's think about that. If I were to hit this, Brianna, go ahead.
so we're talking about if you hit a solid, right? Alright, so if you hit a solid and pretty much if you hit it with a hammer or something, pretty much if it is glass, then it would shatter. But if it's plastic, then I'm pretty sure that it probably wouldn't be called shattering.
Good point. It would be a solid, you're right. And it may just be breaking, not shattering. but good point. And which of these, a solid, liquid, or a gas, will turn to a liquid when heated? Shelby?
Wait, no. Yes, solid.
Very good. A solid will turn to a liquid when heated. So now we are going to get started. This is what you need to do. And I am going to turn my camera off of me, and I'm going to face it down so that you can see what I'm doing as I do this. So you are going to add a 1/4 cup of water and then 1/2 cup of cornstarch. So I'm going to add my water, and I have a 1/4 cup. Now I'm going to add my cornstarch. Now I already have my cornstarch measured out. So go ahead and pour it in. Then you are going to slowly stir it. You're trying to get all of the cornstarch wet. Okay. I'm going to pour the rest of my cornstarch in. Okay, I heard one of you beep in, but I can't see my screen right now, so give me 1 second. Okay, you're trying to make a smooth mixture. Now I'm also going to add a couple drops of food coloring into mine so that it's easier for you guys to see what I'm doing. I'm going to put some blue food coloring in. Okay, and I'm just going to mix that food coloring in. You'll notice as you're adding your cornstarch and your water, it's going to get harder and harder to mix. Now right now mine looks like it has blue stripes. Eventually, as it moves around, the whole thing is going to turn blue. A word of caution to you guys, this is cooking. Make sure you do not touch your computer keys or your mouse with cornstarch on your hands. All right, so go ahead and answer this poll yes. Oops, yes. When your goo is made. Okay, so go ahead and click yes when your goo is made. It's going to be a very weird consistency. Okay, I'm waiting for a couple more people. Go ahead and mix it up. If you're not doing the lab along with me, please go ahead and click yes. I'm waiting for 2 more people. Interesting question, Elizabeth. Elizabeth asked if something can be in 2 states at the same time. Things can have characteristics of more than one state. So something could have some characteristics of a solid, and some characteristics of a liquid, and some characteristics of a gas. It is classified by whatever it has the most characteristics of, if that makes sense. Okay, I'm waiting for 2 more of you to finish your slime. Oh, down to 1 more. Now what we are going to do, once your slime is all made, we are going to perform some tests. Okay, so here we go. Test number 1 is called a quick finger poke test. Now I'm going to move my screen so you can see my booyah. Okay, so here it is. Now a quick finger poke test. I am going to try to get to the bottom of my container here. Super quick. Okay, so let's see if I poke my finger in real quick, what happens? My yuck, I'm not getting anywhere. I'm just getting right to the very top. So, on my piece of paper, I'm going to write down quick finger poke test. And I'm going to write no, because it didn't work. I could not get my finger when I poked very quick to the bottom of my cup. So I'm going to write no or negative. Now the next one is a slow finger poke test. For my slow finger poke test, I'm going to try to get to the bottom of my container in 10 seconds. So let's see if I can do it. I'm just going to count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My finger is blue. I made it to the bottom of my container in 10 seconds. So my answer is yes. It worked, or positive. So next to quick finger poke test, I'm going to write yes. That will save your clothes. Now it says conformity test. For a conformity test, you are going to try to pour into a baggie or a small container. And I'm going to see if it will take the shape of this baggie. So if it takes the shape of the baggie, my test is positive. You don't have to pour it all. It's taking whatever shape I want it to take. So for the conformity test, I'm going to answer yes. it does conform. And we can also answer yes, well, at least I can answer yes to the pour test. Because the pour test says try to pour the mixture from one container or one baggie to another. And I was able to do that. So my answer is yes. Slide number 3 is the bounce test. When you do this, please be careful. The bounce test is to hold the mixture a few inches from the top of your table and drop it and see if it bounces. I'm going to put some in a spoon and I'm going to drop it. So let me move my screen. And mine does not appear to be bouncing. So mine is no, mine is negative. Definitely did not bounce. But now that it's on your piece of wax paper, go ahead and just try to move it around for a minute. Examine it. See what it does and doesn't do. It's a very peculiar substance. Can anyone make an observation about your goo yuck just from touching it? Not necessarily one of these tests. Anyone want to make an observation? Anyone want to make an observation? All right, I'll make an observation. My observation is that I almost feel like I can pick it up, but as soon as I do, it starts to get all gross and run away from me. Anyone else want to make an observation about their goo yuck or their slime, whatever you want to call it? Elizabeth, go ahead.
When you pick up the bag, it looks like it's runny and it appears to be moving like water.
All right, great observation. Xana, go ahead.
It feels slick.
It feels slick. Good job. Anyone else want to make an observation? All right, so we'll go on to the next test, which is the shatter test. So it says put your mixture in wax paper. So put it between two pieces of wax paper and then hit it with your fist and see what happens. If it shatters, it's a yes. If it doesn't, it's a no. Mine was just a no.
Can't hear you.
Our last test is the shape test. So we are going to see if we can form it into a ball. If you can, you have to count to 5 to make sure it holds its shape for 5 seconds. I cannot even get mine into a ball. So for me, the answer to that is no. Those are all of the tests we're going to perform. And for homework today, you are going to answer a couple of questions based on what you just saw and the observations you made. And you're going to make a pie graph or a circle graph like the one on your screen right now. You are going to pick solid as one color, and liquid as one color. You are going to color in. You thought 4 of your questions made you believe it was a solid. You're going to color in 4 spots. And if the rest of your questions made you to believe you were looking at a liquid, you're going to color in those a different color. Now this goo yuck can be saved. You can put it in a Ziploc, and it'll stay in your Ziploc for a few days. It doesn't stay forever. You can take it and you can show your parents, your brothers, your sisters, whoever. All right, so that is our lab for today. Your homework is not up yet. I didn't want people to go ahead on me, so I will put your homework up momentarily. I did shut my screen off, Shelby, because I have blue all over my fingers. So I figured instead of looking at blue hands. But your slime can be saved. I will see you all next week. Make sure you clean up, and if you did get cornstarch on any part of your mouth or anything, you just clean it up with a dry cloth or a little bit damp cloth, but don't get your computers wet. I hope you guys have a great week. Make sure you look at your syllabus to try to figure out what materials you need for next class. If you have questions, I'll stay on for a minute. Otherwise, I will see you all next Monday.
Okay.
Bye-bye, everyone.
Yes, she's.
Just leave it.
Bye.
And goodbye, everybody that's still here.
You know what? I didn't catch all of that. Could you go ahead and repeat that question?
I made this before. And since mine didn't come out right, I just used the one that I already made.
Okay, that's fine. Yeah, you know what? Sometimes it don't come out exactly as we planned, but that's part of science. Not a big deal. Have a great day, Shelby.
Bye.